No doubts.
And can you give a small recap summary of week 9?
Okay, what we can do is solve some questions so that it will revise itself. Will that be okay?
Yes, ma'am. Ma'am, because previous week 9 was not discussed because of quiz 2 revision.
Okay, okay. So I'll try to give it the kind of summary while doing the
Okay, ma'am.
questions. Okay.
Okay, ma'am.
Okay. Should we wait some 2 to 3 minutes, or should we start?
Yes, ma'am, we can wait, I think.
Okay.
And then so tomorrow's morning class will be not there, na?
Yes, it's cancelled.
Okay. Okay, ma'am.
By the way, I don't think so many people were gonna join because this class was scheduled at the last moment, like some minutes ago.
Yes, ma'am.
Actually, ma'am, there is another class going English. That's why I think many people are there.
I think English don't many people attend that, but if they do, it's okay. So I think we should continue now. Yes. Okay, give me a minute. Okay. Okay. Now we can start. So the mainly week 9 is about the sampling rate, time quantization, amplitude quantization, and capacitive mixture. So in the first we have starting from the time quantization. So it's more like when you have so many time, like if you have one signal, so you divide it in so many parts. You make a continuous signal, a discrete signal. Then look at that at every time interval. So you have let's take this till 2 second. So we what is time quantization? We will first take the intervals. Like we will take some small intervals like this. Then we will have something signal like this. So it will be at every time point, and this whatever we are taking this time interval, it would be same for all the signals. In real life, the continuous signals, which are something like this, these doesn't exist. So what we do, we take uh, a large time, and we try to make every signal at every little time intervals. So when you when you do something like this, zoom in, so you it seems like that it is a signal, but actually it is a discrete signal. Like it is not continuous, but if you add those points like here, so it will become a signal. So there, the time quantization comes. Time quantization is like quantizing the time. Quantizing is uh, like limiting a time. And when you go to amplitude quantization, so amplitude quantization is like, mm, let's make it here. So we have this signal, and we are taking some time interval here, 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 and we are taking some intervals in amplitude also. So at this point, we can quantize the signal to this point, and at this point, if there is amplitude quantization here, so instead of going upward, we can quantize to this lower point. So this kind of becomes like become like a ladder instead of a continuous signal, which quite looks like this. So that comes in amplitude quantization. You can go through these lectures. Sir have explained much better than I can. So I can tell the simple ways or formulas which would be easier for you to understand. Okay, so I let me check if I can take anything from here. Okay, see here what sir have done. He have taken uh, time at every interval. If you try to see, uh, the time difference between every interval is 10. If you multiply this 2 1 to 10 minus 1 to 0 0, you will get 10 time interval, 10-second time interval in every after every interval. Will this thing clear? What is time quantization? uh, I want answers.
So, ma'am, what
Yes,
will be
ma'am.
its formula to calculate?
uh, Formula to calculate, we will go through it. uh, Formula is not so different. It's just like they have given this line, and you have to check where this amplitude should quantize to. So which one would be the nearest amplitude, you will quantize to that point. Like see, you have this amplitude, and this is 1.5, and this is 2. So what point would be better for this to quantize? This is some
1.5.
yes. So instead of going to 2, you will quantize this. But when you will quantize to 1.5, there would be some error, right? A very little error. And uh, if you increase the time sampling, like we are taking at 10 seconds, 10 seconds here. But if we increase this, means we started to take this time interval at 4 seconds, so this error would be turned out to be more less, because we are looking at every point every second, so that thing will be less. Is that clear?
Okay, ma'am.
I think this will be more understandable if we go through the questions. And
Yes, ma'am.
after that, we have some questions on switched capacitors. There we have to, it's like you have two capacitors, and they're switching, and the voltage is going from here to there. So let's just take a random question. if you have this 4 volt and this, so I think this one you might already know how this one will charge. What would be the capacitor across VC?
Yes, ma'am.
What's the formula?
VC of T, na?
Yes, what's the formula for this? How we
It
will
will
know?
be V naught into 1 plus C into e to the power minus T by RC.
Okay, so I'm writing it like this. You're
Okay.
telling the same formula, right?
Yes, yes, yes.
Okay. So in this case, you can find simply like this. But if we include some more capacitors and switch thing also, so how we will do it? Let's just include this one more capacitor. And let's just say you have here this is 1 and this is 2, and here you have switch. First this switch is at 1, so what will happen, this 4 volt would charge this capacitor. Okay, so is this thing clear what I did here? Anyone? If it is not clear, I can explain again.
Yes, ma'am. It's clear.
It's just I have added one switch here. So I'm just saying that first, like for some seconds, it is let's take it till t is equals to 4. It is at 1 here, and after that it will switch to 2. Okay. So
So
what?
when it will, like when it is at 1, so normal things happen, which we studied earlier. But when it will be switched to 2, then capacitor 1 will charge capacitor 2.
Uh, then what will happen that this capacitor will try to make the charge same in this one also, because then they will be in series, right?
So ma'am, both will have same charge.
Huh. So both will
Okay.
have same charge and voltage. Charge can be different, but voltage would be same. So here you can find the VC by the earlier method you used to find. Then what will happen when it will switch to 2? Uh, Wait, I have made it the switch wrong. The switch should be something like this. So first when it is at 1, so we will find this VC as we used to, and once it will switch to 2, then this will try to charge this one, and let's just say that the initial charge across this is 0. So this is 0 volt. So how it will charge? So if you know that in the initial, we know one thing, that the initial charge would be equal to final charge, right? So let's just say in the final charge, what will happen, that these two will get added and there would be some final charge. And this charge would be equal to the initial charge across this 1 microfarad, which we can take it for now as C1 and this as C2. So we can write this as C1, and whatever the voltage across this, it's VC as of now, and the voltage, then this C2 into 0 volts. Is this thing clear?
Ma'am, can you again explain this formula?
Okay. I'm just saying here that the initial voltage would be equal to the final voltage. Okay. So in the initially voltage, what would be here? The voltage which was in the C1 and which plus the voltage which was in the C2, right?
Finally.
Uh, that would be equal to final, but initially what would be the total voltage, the voltage across the C1 plus the voltage across the C2.
Okay, ma'am.
Is this thing not clear? Wait.
Okay, like C1 into VC plus C2 into 0 volt. That's what I have you written.
Yes, but let's just take this one. Let's just take this C2 V2. This is the voltage across this, and this is C1, and here we have V1 across this. Is this uh, figure clear? What I've made?
Yes, ma'am.
So what we are saying, that the initial charge, initial voltage would be equals to the final voltage or final charge. So initially, what is the charge bit? Uh, Initially we have this and this, add of them, right? So what's the charge in this C1? What's the charge?
C1 V1,
Yes. And plus what's the charge in this?
C2 V2.
It would be equals to whatever the charge we will get in the last. So if you add them
Okay,
up,
because charge remains conserved.
so in the end what will happen, that these are in parallel, so they will get added, right? So when they will
Okay,
get
ma'am, because final voltage across them will be same. So
hmm,
that's why C1 plus C2 into VF. That's why we got in this.
hmm, hmm. So it would be
Okay.
C1 plus C2 into V final. And this V
Okay.
final we don't know for now.
That's we have to calculate, and so it we can calculate it.
Hmm. So here we
Okay,
have
ma'am.
everything. So we can just simply put the values and find voltage across this. Now is this clear?
Yes, ma'am. Now it is clear.
Okay. So in this case, what we had this VC across this C1 and this 0 volt across this C2. Hmm. So what we are in the
Yes,
first,
ma'am.
what's the charge across this C1?
VC.
Charge.
C1 VC.
Hmm. And we can simply write the VC, we just write the C1. Okay. What's the charge across the C2?
It will be 0.
Yes, because it would be C2 into 0 volt is
Yes.
equals to what's the final charge?
C1 plus C2 into V final.
Hmm. So from here, whenever you have this all thing, we have
So we can
already,
calculate.
yes, we have already found this VC at this point, and then we will put all the values and we will be able to get this V final easily.
Okay, ma'am. Okay, ma'am.
Now this is clear.
Yes, ma'am. Now it is clear.
Okay. So let's just move on to next page. Okay, so now we have. I can tell the formulas of these questions.
Yes, ma'am. You will tell the formula.
Okay, so we have this formula.
So
Free.
I think that in first question, 8 kilohertz is multiplied by 10 second. I think.
Hmm. So the formula is like frequency into time, and this thing would be equals to sampling rate.
Okay, ma'am. Like in question, it is asking how many samples are obtained. So means sampling.
Wait, I think I did something wrong. Let me check this. It is not duration. What? It was written. This is frequent. This is, I think, sampling rate is given. Uh, okay, let's just write it for now. You can do it from this also. So it is samples, and this is not frequency, this is sampling rate. And the sampling rate is just like frequency. So that's why we have kilohertz, we have hertz.
So how we will calculate the sampling rate?
So whenever you have to find the sampling rate, then you would have given the samples and time. But here we have to find the samples.
Okay, basically like 8 kilohertz, 16 kilohertz, these are sampling rates.
Hmm.
Okay. Okay.
Sampling rate, you can say that at what time we are sampling it. In the start, I said no, that we will have so many time intervals. So at what rate we are sampling means at what time intervals we are taking everything, and how many samples we are creating every minute, every second. It's like that.
Okay, ma'am.
So here you can do all these questions from this. We have 8K and time is given 10 seconds. So you can find by multiplying it. You can do this all right. These ones starting three questions. Will you be able to do it?
Yes, ma'am.
Yes, ma'am.
Okay. So the fourth question, in the fourth question we are given the samples. What are the
Okay,
samples?
ma'am. So we can use the same formula like samples is equal to sampling rate into time.
Yes. And we have given the sampling rate also. Now you can simply find the duration. So it would be 352,800 divided by 44100. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So now we have this find the magnitude of voltage step. So whenever you have to find the voltage step, so we have this formula: V final minus V initial divided by levels, and this would be step voltage.
So, ma'am, in this 5 minus 1 divided by 128.
And sometimes you have not given these levels, but you were given the n values, so you can apply this formula: 2 to the power n and V final minus V initial. So it would be like
Okay, ma'am.
n code. So now for this question, this would be solved as we just talked about. But here, this one thing would be different, that whenever you have capacitor which is already charged, so with the resistor, what it will do? Like we have some
Now, uh, initial charge around capacitor.
this capacitor is charged, and it is charged with V voltage. So what will happen now? What will happen because of this resistor?
I think charge will flow, but
Charge will flow, but because of this resistor, it will discharge. This will dissipate energy.
yes, ma'am.
Okay.
So
So
final charge will be zero.
yes, at some point it will be zero. So we can find the last voltage. The voltage would be found like from the discharging formula. So this Vm is V peak e to the power minus T by RC. Okay.
Okay, basically we will use the same formula which we used earlier.
Yes, but it is for discharging.
Discharge. Okay, okay.
You can
Ma'am, but
try.
here we in place of
Say.
ma'am here in formula, ma'am, we will use capacitor voltage.
Which voltage? Can you say it again?
Ma'am, we will use here capacitor voltage.
Uh,
Charge
we we
charge
will
voltage of
will
capacitor.
use this voltage, which is it is charged with. I will
Okay,
just change something.
okay,
I'll say this as V naught. So whatever is the voltage here, that voltage is discharging now.
okay, ma'am.
So now we have this question, seventh. So in this question, what happens? At initially they said that it is at position one for a long time. So I'm just removing this 2 ohm because at when this switch would be at 1, so this 2 ohm would be of no use. So it's like this, 12 volt, and this is 1, this is switch, and here we have 2 ohm, and here we have 4 ohm, and here we have V naught and 1 farad. I'll just quickly tell you this one because it's a bit tough. So you might already know that whenever we have DC voltage, so what happened across voltage? Voltage across capacitor.
Current is equals to 0.
Huh. Current is equals to here 0. So also that here one thing will happen, that we have DC voltage. Because of that, it will not be able to initially charged uh, like at a speed, because we are providing this 12 voltage at once. So you have already stated that voltage in capacitor takes time to charge, right?
Yes.
So the voltage across this VC0 minus would be equal to VC0 plus. Okay, for the first case.
So,
So at that time,
what is what is 0 minus and what is that
the 0 minus is
0 plus?
the initial voltage which was from the starting, and this V0
Okay.
plus is when we put the switch, when we are connecting
On.
this switch to 1, after just like you
Okay.
have 0 and just after that voltage,
Okay.
that
And
0
ma'am,
plus.
I know that the voltage across the capacitance is 0, but why it is 0 current across the capacitor?
Because see, I is equals to C dVc by dt, right?
Yes.
And we are providing the DC current, which is a constant.
Mm.
What happens when
Yes.
you provide a constant? Let's take this. This VC is given as 12 volt. What will happen here?
dt.
What is the differentiation of a constant?
I don't know.
It's zero. We have studied the
Okay.
differentiation, na? That here we have constant. So differentiation of a constant is zero. So we are getting the
Okay.
current across this as zero.
And ma'am, when we use the bridge rectifier like thing, so we use a capacitor, and when we take a power from it, then it's also
Uh,
0.
that will depend on the cases. It will not always be true.
Okay.
So for now, what will happen? That we kind of remove this, or it just we will think of it as that it is not here. So what, how we will find this V naught? We will just simply apply the voltage divider formula. So what would
Yes.
be the voltage across this 4 ohm?
2 by
4 ohm into 12
4
volt.
to 12 by 4 plus 2.
4 plus, sorry, I wrote it as 12 by 2. So from here you will get this is 6, this is 4 ohm, this is 12 volt. You will get 8 volt. Okay. So now the voltage
Yes.
across this VC0 would be also 8 volt, because this thing is in parallel. So the voltage across this capacitor will also be 8
8
volt.
volts.
Yes. And after that, what is happening? That this switch is going to 2. So the new circuit would be what? We will have something like this 2 ohm, this 2 ohm, and this 4 ohm, and there we have this capacitor 1 farad, where we have the voltage across this is 8
8
volts.
volt. Stored voltage.
Yes. Now what you will do? You will find this R resistance. So this 2 ohm and 2 ohm is in series. This will be
4 ohm. And
yes.
4 ohm and 4 ohm is in parallel.
Hmm. So
It
this will
will be
be
2 ohm. 2 ohm
yes.
total.
Yes. So now you can redraw this as 2 ohm,
Yeah. And
and
1 microfarad capacitor is in parallel.
now you can again apply the discharging formula which I have told just, because here we again have this resistor which will discharge, which will make
Yes.
this
Yes,
capacitor
yes.
discharge some energy.
It
So you
draws
can,
the current from the capacitor because it is directly connected to it.
yes. So again you can apply this formula and get your answer.
Yeah.
Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. So now for this question, this is just simple type of question. You have to find the, here we are given this C1, the voltage across this, and we have to find the C2. So first you will add them up, this 4 farad and 4 farad, and first you will try to do is find the voltage across this other capacitors also. So once you will find the voltage across them, you can simply do the voltage divider formula, and you can do one thing, that you can find charge, then simply apply uh, Q is equals to CV. So you have to find the voltage, so you can apply Q by C. So once you will have the charge, you can divide it by the capacitance and find the voltage. We have to find the energy. So you, once you will find this V, so you can apply the half CV square. Okay.
Okay. One thing I want to ask, in a previous question, we thought about that switch first it charge the capacitor, then it discharge. So what concept, in what concept it based on that question?
It is based on the discharging and charging only, no?
Okay, like if we connected for diode in the
Don't
like
don't try to like, don't make it complex. It's just
okay,
simply whenever you have
none.
a voltage resistor and capacitor, so that voltage will charge to some point that capacitor. Okay, the first thing is clear.
Okay, yes,
And then if you have a charged capacitor with a resistor, so that capacitor will charge, will discharge because of that resistor, because the
yes,
resistor always dissipate energy.
yes. I want to ask, like, ma'am, if four resistors of equal value is connected in a in a manner, so we are called as a Wheatstone bridge, that kind of thing. So that's I am asking about this circuit, like a filter or amplifier what type of.
Okay, so you have already studied that filter thing in the
Yes.
earlier one. So there, the same thing was happening. That at some point it was allowing the low frequency and high frequency, and it was
Yes.
based on the voltage thing and discharging and charging. All the concepts mix, right?
Okay.
So it's just like that. You have question, just look at it. What you have to find, and what how the whole circuit is working. Then you can
Okay.
find the voltage and whatever they have asked. It
Okay.
becomes easy when you break it down. Okay, so in this question again we have to find the charge. You can apply the KCL also here, if you know. Also you can do one thing, find the charge, and again you can find it by Q by C. And if you're not able to do it, then ask me on G space. Have you tried all these questions?
No,
No,
ma'am,
ma'am.
not now.
Okay, once try it, or the solution would be provided also.
Okay, ma'am.
Here all the questions are like that. You have to find the charge and voltage, only that. Here again, this is a simple question. uh, it is said that the voltage across this C2, we have 20 volts, and the voltage across this the voltage across C1 is 20 volt, and voltage across C2 is 10 volt. It's like this. It's just like the question we have talked about in the starting. This one, we have given the C1 and we are given the C2. We are given this V1 and V2. We can just simply apply this formula and find this V final.
Ma'am, it is connected parallelly. The voltage across it are different or same?
In the initially it is given different, but as I've said that at some point it will become same. So you will get this V final, which would be same across this both capacitors.
Okay.
So again, this is what it is asked here. You can
Okay.
find it.
This session is recorded, na, ma'am, because I am joined from the mid of the session. So I don't know what.
It is streamed. You can
Okay.
find it on ESTC YouTube channel.
Okay.
Okay, so here it is asked to find the heat, means it is asked to find the energy, which would be found using half CV square. Okay, this week is quite easy. It will not be a very big problem for you. If you just look at some formulas also, you will be easily able to do it.
Yeah. Can you explain the graph? What that graph mean?
Mhm. Wait. So the graph is just simply saying what is the delta. Delta is like the highest time and minus the before time. It's like interval. So
Time
once
So
you,
interval
it will
between
be
the 2 points.
but it is not about asked about the time. It is asked about the amplitude. So we have this amplitude 0.19 and this 0. So how we will find this delta? It would be, you can think of it like a n plus 1 minus a n. I think this might seem
so I'm along y-axis or x-axis.
voltage is this y-axis,
Okay.
because it is asked amplitude, no? So amplitude is always like this, no? Y.
Okay. And X is also, ma'am, voltage in input voltage and input voltage both.
It would be input voltage most probably. Okay, so And the codes are these, the levels: 1 2 3 4 5 6 7 8. So these are the amplitude levels which are code.
Okay,
Okay.
but what that graph represent? Can you explain little bit?
It's just what I have told in the starting. You are quantizing the amplitude. You are taking this a big signals
Okay,
and
okay. Taking its
uh,
at a one point like that.
you are dividing the amplitudes in so many levels, and then taking whichever would be the near of that voltage, so that you can
Mm.
digitally analyze that.
And when then we quantize, taking its rounding off.
Hmm. And this is necessary because computer only understand this level. Because in the end, these things will be changed in 1001 kind of thing,
Yes, yes.
which would be taught in the week 10, I guess. It's in week 10. And for this question again, this V1 will charge this capacitor C1 as a V1, and this C2 will charge it to V2. Then again, when the switch will be closed, you can apply that voltage formula, this one, which we have studied here, and you can find the V final.
Ma'am, is that circuit valid because the only positive terminals are on the upward side? When it is attached, then
It then the downside was grounded, no?
grounded. Yes,
So there is no problem
but
in
it is
it.
connected like a parallel connection. If we turn on that switch,
Huh.
and what the capacitor do there?
Capacitor, you have to find the voltage V final. There is no work satisfied for this. It's storing voltage. Again, in this question, you are given the voltage across these capacitors, and again, you have to apply this formula. You will find it. It would be
So
better.
rest all are only base same concept basically.
Huh. That's why I said that it would be easy for you to do all this question, even if you just go through this lecture. So
Okay.
we can talk about this question. So it's like whenever the frequency increases, what will happen? It is as the frequency of analog signal increases, then which of the following need to be considered? Whenever the frequency increases, what will happen to time?
Decrease.
Time decreases.
Yes. Huh. So the time is decreasing. So sampling rate would be, what will happen to sampling rate?
Increase.
It will increase
Decrease.
because then uh, because then we will have small intervals, means we are sampling at every little intervals. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay.
I think
Uh,
now we can do this type of questions.
and again, this formula. So comparator, for the comparator, I am writing the formula here. So for comparator, it is level minus 1. And if you are given the number of these level or in binary, because sometime it would be given this n value as 4, then you have to find the comparator. So then you can put it here and find it. But for in this question, you can tell levels now, right? Can you tell me the levels?
So ma'am, to tell levels, like we have to also include the zero level.
Hmm. 1 2
Ma'am,
3
nine
5. Yes. So the levels are here is 9, and when we do minus 1, we will get 8.
comparators.
And now for this question, it's again the same type. You can do it once by yourself. And for this energy, again, you just have to apply the formula we already know, half cv square.
Okay, ma'am.
For the
And now,
initial volt, let's just talk about this initial energy and final energy ones. So we have this. So for initial, what would be the energy across this V1 C1? What would be the energy across this V1 C1? See, we know the formula,
Half CV.
half
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 CV
CV.
square.
of C1 V1 square
Yes, ma'am.
plus the energy across this. It
Again,
would be,
half C2 V2 square.
yes. And after that, when we will get this final voltage, then what would be the energy?
The
Final,
energy will be half into C1 plus C2 into
C2.
final voltage square.
huh? Yes, you got it. So this is, I think, enough for this week.
Yes,
Yes, there's
normal.
no any other thing. You can just do all the question using these.
Okay, ma'am.
Otherwise,
So
I'm
next
there
session
in
will
this.
be cover the week 10 concept or week 9.
It will be based on week 10. The first session would be on week 10 summary.
So the next session will be day after tomorrow, no? On
Uh,
Friday, not
that I
tomorrow.
have to check. Let me check once.
Today's lecture
Yes,
is week 10 summary.
this is week 9.
Okay. No, in a corner this is written. That's why.
Uh,
Week.
in the corner, it is written that week 10 summary, right?
Yes.
It's written wrong. So
Okay.
you will have the class on Friday, 9 a.m. week 10 summary.
Okay, ma'am.
And anything else?
No, ma'am.
Okay, so
No, ma'am.
also please, huh? See?
Okay, ma'am. So tomorrow's morning class has been scheduled down. Huh? That's why.
Mhm.
Okay, ma'am. Thank you, ma'am.
Thank you. Also, please
Yeah.
attend the discourse questions also.
Yes, ma'am. It is released.
I will release it today or tomorrow.
Okay, ma'am. One thing I want to ask in the previous quiz, previous session, recorded by you, the solution of that.
Solution of the mock.
Quiz 2, previous quiz 2 solution video.
Yes. Previous quiz two. You mean the previous session which I have taken, no? About quiz two.
Mm, not this quiz 2, previous term quiz 2.
Okay. I have not remembered the questions, but you can ask.
Yeah, but how can I ask? That is a circuit based question.
Uh, Wait. Let me first stop the streaming. Then we can continue. No doubts left, right?
No, ma'am.
If
Can
anyone
we?
wants to leave, they can.
Thank you, ma'am.
Thank you. You can screen share.